بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Dear grade 10 students, hello and welcome to this video. Today we're going to revise some basic rules of indices. We're going to cover negative indices and we're going to work with some special powers. Let's start our lesson today by revising what we have learned previously. Exercise number 1, guys, is actually about the rule of multiplying indices. And here we are given 3 power 2 multiplied by 3 power 3. And in order to multiply these indices, all you need to do is to keep the base without any change. And here you need to add the 2 powers. So the result will be 3 to the power of 5. The second part, guys, is also about multiplying indices. But here we are given coefficients. So let's start by multiplying the coefficients first, and then let's deal with the variables. 4 times 2 equals 8. And here we have 8 to the power of 2 plus 6, which is equal to 8 to the power of 8. The second question is about how to divide indices. Here we are given 2 indices with the same base, so all you need to do is to keep the base the same and subtract the 2 indices. So it will be x to the power of 10 minus 4, which is equal to x to the power of 6. The second part of the question is also about how to divide indices, but here we are given coefficients. Just like multiplying indices with coefficients, let's deal first with the 2 coefficients. So here, guys, 25 divided by 5 simply equals 5. After that, we have b to the power 7 divided by b to the power 3. And now we need to subtract the powers, so we will have 5b to the power 4. Question number 3 is when you are given a power raised to another power. Here, guys, we are given 7 to power 3, all is raised to power 4. And all you need to do is to keep the base without any change and then multiply the 2 powers. So it will be 3 times 4, and this will be 7 to the power of 12. The second part of the question is also a power raised to another power. But here, guys, we are given this brackets, and inside the brackets we have 3 factors. So we need to distribute the power to every single factor inside these 2 brackets. So 3 will be 3 power 2. A power 2 will be raised to power 2, and b power 3 will be raised to the power of 2. To simplify this expression, it will be 9. A power 2 to power 2, it will be a 2 multiply 2 equals 4, b to the power of 6. For this very quick revision, let's start our today's lesson, our today's topic, which is negative indices. Before I explain what is the meaning of negative indices, okay, let me ask you this question. What is x to power 2 over x to power 3? We know that we can deal with this fraction, we can deal with this expression by 2 different ways. The first one is to expand each of these powers. So it will be x multiplied by x, and x power 3 simply x multiplied by itself 3 times. And now, guys, we can cancel x and x, so we have left 1 over x. And with the same expression, we can simplify it using a different method, which is the rule of dividing indices. So here we have x to the power 2 minus 3. It means the result will be x to the power of negative 1. And here, guys, we have already a negative index. And from these and from this example we can identify that x to the power of -1 simply equals 1 over x. So it will be our today's lesson. So it means that means x to the power of -1 simply equals 1 over x. So guys, from the previous example, we could understand that x to the power. So guys, from the previous example, we understand that a negative power or a negative index is just a convenient way of writing the reciprocal of a number or a term. It means if you have x to the power of -1, we can write down x to be x over 1 all to the power of -1. And actually we did nothing. We didn't change anything because x simply equals x over 1. And in order to get rid of the negative index, all you need to do is to write down the reciprocal of the number in this bracket. So instead of x over 1, it will be 1 over x to the power of 1. So guys, whenever you are given a negative index, so think about the reciprocal of the number. In order to get rid of the negative sign of the power, you need to flip the number inside the bracket. Let's have some examples. So let's start with the first question. Here we are required to write each of the following in fraction form. So guys, you need to get rid of the negative sign of the power and rewrite this in a fraction form. So first question, we are given 5 to the power of negative. The best way to think about this problem is to rewrite the number 5, the base, to be a fraction. It will be 5 over 1 raised to the power of -3. After that, in order to get rid of the negative power, you need to flip the fraction. You flip the fraction and then write the fraction to the new positive power. So guys, you can now deal with this fraction by distributing the power into the two terms. It will be 1 to power 3 over 5 to power 3, which is equal to 1 over 5 to the power 3. If you want to expand 5 to power 3 to be 125, you can do it, but you can also leave the answer like this. And now let's move to B. We have 1 over 2 to the power of -1. And here we are given the base as a fraction. So all you need to do is just flip the fraction. It will be 2 over 1 to the power of, instead of -1, since we flipped the fraction, so we can write down the power in positive sign. It will be 2 over 1 simply equals 2. As we are given 7 to the power of -2, you have the choice. If you want to solve it in steps, in details, you can do it like this. Just make a fraction and then flip the fraction and get rid of the negative sign, but you are not required every time to write it like this, to solve it like this. So it will be, with practicing, I think it will be very easy to identify the result without even thinking about how to flip the fraction. So it will be 1 over 7 all to the power 2, which can be 1 over 7 to the power 2. And now let's move to D. Here we are given that 4 times m to the power of -3. Here guys, we need to differentiate between two different things. Here -3 actually belongs to m only. So 4 is not raised to any power rather than 1. So here we need to deal with m to the power of -3. So 4, we don't have any problem with 4, just drop it 4, and we have now m to the power of -3. Here we multiply 4 by 1 over m to the power 3, which is actually 4 over m to the power 3. Now let's go to E, and here we have the same idea. Here we have 4 over 5 y to the power of negative 1, and here you need to ask yourself, negative 1 belongs to y or belongs to the entire expression? Actually, since we don't have any practice between these two factors, since we don't have brackets right here, so y only is raised to the power of negative 1. So we don't have anything to do with 4 over 5, just drop it like this, is multiplied by y to the power of negative 1 simply equals 1 over y, and the result will be 4 to the power of 5 over y, and now let's move to f. And here, guys, we have the entire expression is raised to power of negative 2. For a, all raised to the power of negative 2. So you need to think about this base as one quantity. So in order to make it, think about this quantity as a fraction for a over 1, all to the power of 2. Sorry, of negative 2, since we didn't flip the fraction yet. After you flip the fraction, you have the ability to get rid of the negative sign, so it will be to power 2, and by distributing the power, it will be 1 over 4 power 2 simply equals 16, a to the second power, or power 2. Now, guys, let's move to example number 2. And here we are required to write these expressions in a negative index form. So we need to perform the opposite process. Now we are given the expression in fraction form, and now we need to convert it back into negative index form. So let's start with a. Here, guys, we have 1 over 3 power 2. We can think about this one. Why don't we make it like this? 1 over 3 all to the power of 2. Since 1 power 2 equals 1. And now, guys, if you need to put a negative sign right here to solve this question, all you need to do is to flip the fraction inside the brackets. So it will be 3 over 1. And now you can add the negative sign, so it will be to the power 2. And since 3 over 1 equals 3, so it will be 3 to the power of negative 2. Let's move to b. Here we have 1 over t to the power of n. And here, guys, we can solve it using the same method. Here we have 1 over t all to the power of n. Since 1 to the power of n equals 1, so we didn't make any change right here. And then, in order to add a negative sign to the power, you need to flip this fraction, so it will be t over 1 to the power of negative n. And simply equals t over 1, it will be t to the power of negative n. Let's move now to c. And here we have 10 to the power of b. And here we have 10 over b. This fraction form needs to be in a negative index form. So, guys, you can think about this expression like this. We have 10 actually multiplied by 1 over b. And we don't have anything to do with n. We don't have anything to do with 10, so drop it as it is. And now, guys, think about 1 over p to the power of 1. In order to make a negative index, so we need to flip the fraction inside the bracket. So we have 10 to b over 1 to the power of negative 1, and it will be 10b to the power of negative 1. The same we have right here. Here we have 5 over a to the power 3. So you can pause the video and find out the answer on your own. Okay, guys, okay. We can find out the answer by using the same process that we used right here in C. It will be 5 times 1 times a to the power 3. Simply, without doing all these steps, I can say that it will be 5. 1 over a to the power 3 simply equals a to the power negative 3. And we have done with all these examples. Example number 3, we have two different numbers can be written in the form n to the power of n. The sum of the numbers is 40, and we are required to find out the difference of the two numbers. So guys, let's think about two numbers can be written in the form 2 to the power n, which means an integer. When you add them, you get 40. So let's list two different powers. 2 to power 2 simply equals 4, and here 2 to power 3 equals 2 times itself 3 times, which is 8. 2 to power 4 equals 16. 2 to power 5 equals... Here guys, what are the two numbers? When you add them, you get 40. Yes, it's 8 and 32. So the two numbers actually in the form 2 to the power n, 2 to power 3 plus 2 to the power 5. And since we are required to find out the difference of the two numbers, so we can find out the difference between 2 to the power 5 minus 2 to the power 3. And actually we cannot apply any rule because we don't have any to deal with this one, except for expanding each number to be 2 to power 5 simply equals 32 minus 2 to the power 3, which is 8, and the difference between them will be... Okay, so since we are required to find out the difference between the two numbers, so the difference is 16, and of course 16 could be written in the form 2 to the power of 4. But actually I need to stress that we cannot deal with this subtraction with any rule of indices. We need to expand each power and just subtract them like this. And now guys, let's talk about some special powers. First, power 0. Any number rather than 0 to the power of 0 equals 1. And it makes sense, but actually we can prove it. So for example, let's think about 7 to the power of 3 divided by 7 to the power of 3. Actually, we know that when you divide any number by itself, the result should be 1. It's logic. And actually, we can deal with this situation by using the rule of dividing indices. So 7 power 3 divided by 7 power 3 simply equals 7. And you need to subtract the powers, so it will be 3 minus 3, which is equal to 7 to the power of 0. And now guys, we can identify that 7 to the power of 0 simply equals 1. And this is and we can write down the general rule for this by x to the power 0 equals 1. For one exception. 0 to power 0 actually is undefined quantity. Second special power we're going to deal with is power 1. Any number to the power of 1 equals the same number. X to power 1 simply equals x, and we always write x to be like this without power. Right here we have actually invisible 1. So whatever you have a variable, so this variable actually is raised to power 1, but we don't write this power. Third one, whenever you have negative 1 raised to an odd number such like 2, it means negative 1 multiplied by negative 1, and the result will be positive 1. So guys, we can generalize this rule to be what? We can generalize this rule to be this. Negative 1 to any even number, negative 1 to an even power simply equals 1. And negative 1 to an odd number equals negative 1. Let's prove it. Imagine that I have negative 1 to the power of 3 simply equals negative 1 multiplied by itself 3 times. So let's have a look what we have right here. So guys, negative 1 multiplied by negative 1 will be 1 multiplied by negative 1. So Positive times negative simply equals negative. It will be negative 1. Negative 1 raised to any even number, so the result will be 1. So negative 1, for example, to 150, it simply equals 1. Similarly, if you have negative 1 is raised to any odd power, for example, 159, so the result will be negative 1 without doing any operation. Okay guys, that's it for today's lesson. See you inshallah later on, and we're going to cover fractional indices in the next video. Thank you so much. Have a nice time. Bye bye.